In this video, we're going to pick up where we left off at the end of our last video, which was an introduction to redox reactions, oxidation and reduction. We talked about the definitions of reduction, oxidation, redox reaction, and half reaction. And in this second part of the video, we are really going to focus on our second learning goal here. We're going to make sure we've done lots of practice problems to determine whether or not a half reaction represents oxidation or reduction, using the location of the electrons in the reaction equation and the starting and ending charges of the atom or ion. So we're just going to do lots and lots of practice now. Let's get to it.
First practice question. Which reaction equation represents oxidation? So we have a couple of different options of combinations. We've got nickel with a charge of 4 plus versus nickel with a charge of 2 plus. And we're trying to figure out whether the electrons should be drawn on the reactant side of the arrow or the product side of the arrow. So take a moment to annotate each answer choice and to write out in words what it's really saying to us, just the same way that we did in the first video with the copper problem. Then decide, based on how you wrote out the words, which reaction equation best represents oxidation, remembering oil rig as our mnemonic for how to remember what's happening during oxidation and what's happening during reduction. Pause the video if you need more time. I'll go over the answer as soon as the countdown stops.
So let's quickly go through what each of these reactions is kind of telling us in words. So in A, electrons are on the reactant side. That means that a positive 4 plus ion is gaining 2 electrons to become a positive 2 plus ion. In B, we have a positive 4 plus ion breaking apart into a positive 2 plus ion plus 2 electrons. So B is showing losing electrons. Again, thinking about where the electrons are located on which side of the reaction arrow is the key here. If the electrons are located in the product, we are looking at, but not in the reactant, we are looking at losing electrons. If the electrons are located in the reactant but not in the product, we are looking at gaining electrons. In C, we have a positive 2 plus ion losing 2 electrons to become a positive 4 plus ion. And in D, we have a positive 2 plus ion gaining 2 electrons to become a positive 4 plus ion. Let me just first eliminate the answer choices that don't make sense based on what we know about electrons. So D does not make sense. If an ion has a charge of 2 plus and it gains 2 electrons, it would then have a neutral charge because electrons are negative. So D does not make sense. So the answer cannot be D. The answer also can't be B, because if a positive 4 plus ion loses 2 electrons, that would actually make it a positive 6 plus ion. It would get 2 units more positive by losing 2 electrons. So D and B I can eliminate. Now, oxidation is going to be losing electrons. So the answer is C. A positive 2 plus ion loses 2 electrons to become more positive, a positive 4 plus ion. That one's a little tricky because there were no neutral atoms here. Let's do the same question. I'm going to leave the annotations up, but now let's think about which equation represents reduction. So reduction is gaining electrons. We've already eliminated option D because it didn't make sense for a positive 2 plus ion to get more positive by gaining electrons. So the answer is A. A is showing us reduction because nickel with a charge of 4 plus is gaining 2 electrons and becoming a little bit less positive, right? 4 minus 2 is 2, so its ending charge is 2 plus. Nickel 4 plus has been reduced to nickel 2 plus. Last couple questions. Let's think about which reaction equation here correctly represents oxidation. Pause the video if you need more time. So let's annotate each of our answers here. A, I have neutral silver gaining 1 electron to become a positive 1 plus ion. That's what that reaction equation would read as. B shows a positive 1 plus ion losing an electron to become neutral silver. C shows neutral silver losing 1 electron to become a positive 1 plus ion. And D shows neutral silver gaining 1 electron to become a positive 1 plus ion. So I know that oxidation means losing electrons, so it has to be B or C. And so now I just have to think about which one actually makes sense. If I'm looking at C, neutral silver loses 1 electron to become a positive 1 plus ion. That seems to make sense. Losing an electron should make it more positive, right? B, on the other hand, doesn't really make sense. If a positive 1 plus ion loses an electron, it would become a positive 2 plus ion. It wouldn't become a neutral ion. Again, electrons are negative. When you lose an electron, you become more positive. So C, neutral silver with a charge of 0, loses 1 electron to become a positive 1 plus ion. Last question of the video, we're going to do the same set of reactions. Which one represents reduction? So reduction is gaining electrons. So the question is if it's A or D. If neutral silver gains an electron, it's not going to become a positive ion. So the answer can't be A. The answer is D. Reduction in this case would be a positive 1 plus ion gaining an electron to become neutral silver. Again, picking through these questions, looking very closely at where the charges are, where the electrons are located, where the reaction arrow is located is key here. And this does take some practice. We're going to be continuing to think about redox reactions in future videos for a little while. Hopefully after all that practice, you feel more confident looking at a half reaction and deciding whether or not an element or an ion is being oxidized or reduced. It's important to be able to look at these half reactions and think about what we can learn about where the electrons are located in the reaction, because it will help us to better understand redox reactions as we start to write the full reactions instead of just looking at the half reactions. Awesome job today.